Group 12 is pleased to present the following presentation as a brief outline for the research article entitled Influence of Urban Heating on the Global Temperature Land Average Using Rural Sites Identified from MODIS Classifications. The presentation has been prepared by Eric Lips, Taylor Marous, and Troy Nahandian. The Berkeley Earth Temperature Study is an ongoing research effort that records the average temperature of the Earth's surface in an effort to analyze the global warming phenomena. Global warming temperature measurements consist of various temperature stations located worldwide. Some of these temperature stations date back to the pre-industrial revolution around 1850, while others have recently just been added as data points. Of those temperature stations, a disproportionate share of them are located within or very near urban areas, where temperatures can be expected to be mildly warmer than their rural counterparts. This has raised the concern that there may be an inherent error in the methodology of the Berkeley study. The goal of this research article is to provide evidence or not that urban heat islands have an effect on the Berkeley study of overall increasing Earth land temperatures. The Berkeley study, as well as this article's research, utilizes nearly 37,000 temperature stations from the Global Historical Climatology Network Monthly located around the world. As stated, there has been controversy over the study because of possible urban influence on the temperature stations. To make a point, 1% of the globe is urbanized, while 27% of the stations are located in urban areas. Three major agencies present research information regarding global temperatures utilizing the same network and compiling their findings in regard to global warming. These three agencies are NASA Goddard Institute for Space Science, also known as GISS, National Oceanic and Atmospheric Administration, also known as NOAA, and the Hadley Centre of the UK Met Office, and the Climate Research Unit of the University of East Anglia, also known as HAD-CRU. All of these agencies account for urban heat island effects within their global warming research. However, they utilize different methodologies from one another as well as a subject article. To account for urban area effects on global average temperatures, the three agencies' approaches are: for the GISS team, identifies urban, near urban, or rural stations by their locations based on nighttime satellite imagery. They then remove those urban stations from their average temperature studies. There are some problems with this approach, though, of which are: not all worldwide cities necessarily have a multitude of lights. In other words, developed nations' urban areas will have a large amount of light sources, whereas lesser developed nations will contain lesser amounts of light sources. An urban area, say Pyongyang, North Korea, where electricity is scarce compared to, say, New York City, will not be accurately depicted on the satellite imagery, and therefore station locations will certainly be mislocated in an urban or rural area. Therefore, this is a socio-economic bias using satellite imagery of night lights. Fewer lights equals rural, and more lights equals urban, though urban boundaries may not coincide with light boundaries. Another issue with the GISS method is the precision of the Berkeley dataset stations locations, some of which only are reported to the nearest 1/10 of a degree in latitude or longitude. In many cases, that could place the station location either in an urban area or rural area within the satellite imagery. For the NOAA team, urban sites are excluded by use of an automated process of pairwise comparison. In short, this is a process of comparing two stations based on historical records and assessing a mean so as to identify whether the pair should be classified as rural or urban. The process involves quantifying two stations based on the mean of the two. As one can anticipate, this can cause problems. 1. If the station records are not kept up to date or experience large gaps in record keeping, any one station site could easily be placed in the wrong category. 2. Using pairs of stations and obtaining a mean to classify them will present the problem, especially if the pairs are very distinct apart. For instance, say two stations are located 100 miles apart. One indicates from historical records as being always urban, and the other indicates to be suburban. The mean would place the stations somewhere between urban and suburban, and given the fact that it can only be classified as urban or rural, the two stations will be placed in the urban category. But what about the 100 miles in between? This may be an extreme example, but it is evident that this method is certainly not without its flaws. The HAD CRU team only suspected urban sites are excluded. They only provide for urban heat island effects by compensating for it using an uncertainty factor. This may be a very well-formulated statistical guess, and the article does not expressly indicate how HAD CRU carries that out. But we would have to surmise that this does not sound the most promising way of sorting out urban stations. Now for this article's research. This article takes the classification of stations a couple of steps further than the GISS team. 1. Rather than using lower resolution satellite imagery, it utilizes the MODIS Urban Classifications Map, shortened to the MOD 500 map. The map has a much higher resolution than any previous satellite imagery. This satellite and corresponding software uses sophisticated algorithms, which will not be discussed, allows for identification and mapping of urban areas on land cover. Since this is not based on availability of lights, more accurate identification of urban areas is attained. 2. To compensate for the imprecision of station locations, some indicated only to nearest tenth of a degree latitude or longitude, all stations within 1/10 of 1 degree of an urban area as identified on the MOD 500 map are excluded. In essence, this article's approach much more adequately removes any temperature station that may remotely have urban heat influence. It is hoped that with the removal of those stations with even slight urban heat influence, only very rural stations remain in the dataset that can be studied to see any temperature analysis based solely on stations that have never been affected by urban heat. You may still be asking, why are we sorting out the urban stations from the Berkeley dataset? As stated before, a large number of the dataset stations are located in urbanized areas. We know that urbanized areas tend to have higher ambient air temperatures. Since the Berkeley dataset does not exclude those stations, there is some controversy that those disproportionate number of urban sites alter global warming research as being larger than what there actually is. In other words, urban heat islands are erroneously affecting global warming research, and that perhaps, as may be argued by some, global warming is not as drastic as what is reported. To find the urban influence on overall data, we need to perform a temperature trend analysis on just very rural sites, and subtract that trend analysis from an overall all stations trend analysis. This will yield a range that can be graphed and would indicate any urban influence on global warming over temperature station history. A flat slope of range, or line, would indicate zero urban influence. A positive slope of line would indicate urban heat islands are influencing the overall Earth temperature, and negative would indicate the opposite. Again, the methodology of this article is to nearly unequivocally remove all urban temperature stations and rely on very rural stations trends in order to disprove or prove urban heat island effects on global temperature. Unlike other studies discussed, this article's research removes any station site within 1/10 of a degree of an MOD 500 urban area out of the dataset. This article considers those sites outside of that limit to be very rural, and those within that limit to be not very rural. As briefly mentioned before, the dataset utilized for the study comes from the Berkeley Earth Temperature Study. This temperature readings from 36,869 stations located worldwide all available from 15 public sources. Using this article's study methodology of urban station removal, 15,594 stations are classified as very rural, leaving the majority of the stations, 21,271, as having some form of urban influence and removed from the dataset. A station trend analysis was performed on each station under the very rural classification, as well as a trend analysis for all stations. This method simply uses a best fit line for all temperature readings through history. An average trend analysis is drawn by taking the average of all stations best fit for both categories, all stations and very rural stations. All stations are further subcategorized by average temperature increase or decrease in 1 degree increments, as well as being subcategorized into station history length. There are limitations to this approach though, of which are younger station trend lines will reflect larger temperature fluctuations based on statistical fluctuations of temperature readings, and may not necessarily be balanced out by long-term trends that a larger sampling would provide over a longer history. The study only provides an average of station temperature readings over time. It is not average readings over equitable distribution of land and station distribution. The study is simplistic and does not categorically remove all errors. Even though the very rural stations should exhibit no urban heat island effects, the study reveals the difficulties in demonstrating the heat island phenomena. It should be noted that the method utilized, trend analysis, though biased to some degree, just based on weak station location distribution. It is a straightforward way of comparing the differences between very rural and all stations' temperatures trends. The very rural station trend lines result in about twice, 65% versus 35%, as many stations showing a positive increase in temperature. This appears to indicate that even with removal of all urban influence, the most isolated temperature stations around the globe still indicate that there is global warming. Even though many stations experienced large time gaps in recordings, notably those that were historically older, the ratio of warming trends to cooling trends is 2:1. So nearly double the amount of stations indicate global warming, while the rest show cooling. Extraordinarily, the very rural warming trend is actually greater than the warming trend illustrated by all of the stations. This is actually opposite of what would be expected for urban island influence. Two histogram plots were plotted. One is for all stations and one is for just the very rural stations. Both indicate a warming trend. The stations were categorized by their age also. Notice that the peaks of all historical age groups on the histograms are slightly to the right of the center, where it is indicative of a positive increase in temperature. Though there are a great deal of stations indicating decreasing trends or increasing temperature trends, the vast majority are demonstrating a slight increase in temperature per every 100 years. Standard errors are obtained by bootstrap resampling, also known as sampling with replacement. Of all 36,858 trends, calculating the median trend in each group, and using the standard deviation of the group medians to estimate the standard error in the overall median. They do not take into account the spatial correlation of the trends and hence underestimate the true uncertainty in the estimate of the median trend. Table 1 shows evidence of global warming, using all the records there is, a median warming trend of 0.96 plus or minus 0.04 C per 100 year, with a 2 sigma error. The estimated warming trend for the very rural group is larger than that based on all records, in the opposite direction expected from urban heating. Although trend analysis is a very crude way to look at global temperature change, it illustrates important features of the data. Differences observed in this analysis reflect that there are many sources of variation in individual station trends that contribute larger effects than any effect due to urban heating. regardless of newer stations with more variable temperature readings because of statistical fluctuations, or older, more temperature-consistent stations. The difference between stations is negligible. Figure 5A shows the comparison of the temperature estimate for the all land sites in red with the temperature trend for very rural land sites in blue. The difference between the two plots is shown in Figure 5B. An urban heat island bias would be expected to show itself as an upward trend in 5B. None is seen. Over the bulk of the record, the difference between the two calculations is consistent with zero within two standard errors, shown as the light gray area on Figure 5B. The standard errors are calculated by adding the statistical uncertainties calculated for each average, using the jackknife method of rote and quadrature. The results of this analysis are in line with previous results on global averages despite differences in methodology. Parker concluded that the effect of urban heating on the global trends is minor. HAD CRU uses a bias factor of 0.05 C per century, and the NOAA estimate residual urban heating of 0.06 C per century for the USA, and GISS applies a correction to their data of 0.01 C per century. All are small on the scale of global warming. The station slope analysis shows that there are also a large number of sites with negative trend lines. Some of these could be due to cooling effects resulting through anthropogenic changes to the landscape. For example, if asphalt is changed to concrete in an urban area, we might expect the solar absorption to decrease, leading to a net cooling effect. Note that the averaging procedures used consist only of land temperature records. Inclusion of ocean temperatures will further decrease the influence of urban heating, since it is not an ocean phenomenon. Including ocean temperatures in the Berkeley Earth Project is an area of future work.